Hey guys, today we're going to just do a quick review of enzymes. So I wanted to quickly just define enzymes for you. An enzyme is a protein, usually, that acts as a catalyst. And to be a catalyst means that you speed up chemical reactions, and you do that by lowering the activation energy. Activation energy is what you usually have to do to get a reaction to happen. Most of the time activation energy is heat. So if you have two substances that you want to react together, they don't just spontaneously combine or spontaneously fall apart. You usually have to cook them with heat or add some electricity or something like that to force them to come together or to separate. And that energy that you put in the form of heat or electricity is the activation energy. So when you add an enzyme, the enzyme will lower that energy, so you don't have to cook it as much or as hot, or you don't need as much energy. The other thing that's important about enzymes is that they're specific to their substrates, and this is because of shape. Shape is really important to protein functions in general, but especially to enzyme functions. So if you look at this enzyme here, which substrate would it break down? Would it break down substrate 1 or substrate 2? And if you look, obviously the shape of the active site, which is this area here, the active site, matches substrate 1, right? Substrate 2 wouldn't fit in there because it doesn't have the same shape. And so because of this shape specificity, the enzyme is very, very specific. All right, so let's look at how enzymes react with one another. First of all, this is our enzyme right here. This is our substrate. When these two combine, they form this, which is called the enzyme-substrate complex. Then notice once the substrate is broken down into its two component parts, what you have left is the product, which is what these two component parts are here, and then the enzyme. Now what's important to notice here is that the enzyme shape doesn't change. Look at the enzyme here, here, and here. The whole time the enzyme stays the same shape. And what's important about that is it means that the enzyme is actually not consumed by the reaction that it catalyzes, which means once this enzyme is done making our product, that enzyme's free to go back and pick up more products that, or excuse me, more substrates that look like it would fit into the enzyme. So one enzyme, for example, is capable of handling a lot of molecules because it can react with them and then go back and pick up more molecules. So the enzyme is not consumed. Now what you are seeing is a catabolic reaction here, and the name is not that important, but do understand that the reaction is simply a splitting up reaction. So the arrows that you see going in this direction are catabolic. If you wish to do an anabolic process where you're actually putting molecules together, you would simply reverse these arrows. So you would go in this direction instead. So here what would happen is this and this would be the substrate. They would go into our enzyme and make the enzyme substrate complex, and then our product here would be the two components put together. So enzymes can actually do both. They can actually put things together or take them apart. Either way, though, what's important to notice, again, is that the enzyme doesn't change shape. It's not consumed by that reaction. All right, finally, what's important to note is that enzymes are controlled by several things, and the first of these is concentration. When we say concentration control, what we mean is that the enzyme can be more concentrated. You can add more enzymes to a reaction, which would obviously speed it up. Okay, so in general, more would mean more speed. You could add more substrate without changing the enzyme's concentration, and then what's going to happen is the enzyme is just going to get so fast, and then the enzyme can only work as fast as it can work, and so your speed will kind of plateau. So you'd get a graph of speed that looks like that, and it would just kind of plateau and stay there unless you added more enzyme. So concentration of enzyme and also concentration of substrate. As you reduce the concentration of substrate, that's going to eventually slow down the reaction, so eventually your graph would do that, right? Two other things that are important are temperature and pH, and I know in biology you learned about temperature and pH. Specifically, very high temperatures and very low pH can do something called denaturing the enzyme. Salinity or high salt concentration can also denature an enzyme. And denaturing an enzyme happens when the enzyme changes shape. So our enzyme that looked like this suddenly changes its shape and it looks like this. Okay, that's denaturing. So high temperature, low pH, or a lot of salt causes the bonds that are holding the molecule into this shape to kind of fall apart, and then the enzyme turns into something like this. And as you can see, this is no longer going to act on our substrate. So the enzyme is now effectively pretty much useless in this case. Other things can denature as well. Other proteins can denature. It doesn't just have to be enzymes that denature. So anything that's proteinaceous, if you heat it or you drop its pH or you add a bunch of salt to it, any of those things can actually cause the protein to denature as well. But that's your quick review of enzymes. There we are.